Shallow foundation. Have you ever wondered how buildings stay firmly on the ground without sinking? The answer lies beneath our feet in the foundation. In this video, we'll explore one of the most common types of foundations used in construction, the shallow foundation. We'll learn what it is, where it is used, its types, advantages, and limitations. What is a shallow foundation? A shallow foundation is a type of foundation that transfers the load of a structure to the soil located close to the ground surface. Generally, the depth of a shallow foundation is less than or equal to its width, and it is usually constructed at a depth of up to about 3 meters, depending on soil conditions. These foundations are suitable when the soil near the surface has enough strength to support the building safely. Where are shallow foundations used? Shallow foundations are commonly used for residential houses, schools, small office buildings, warehouses, low-rise commercial structures. They are ideal where the soil has good bearing capacity. The groundwater table is not very high. Structural loads are moderate. Types of shallow foundations. 1. Isolated footing. An isolated footing supports a single column. It is the simplest and most economical type of shallow foundation. It can be square, rectangular, or circular depending on the load and design requirements. 2. Combined footing. A combined footing supports 2 or more columns using a single foundation. It is used when columns are close together, or when one column is near a property boundary. 3. Strip footing. Strip footing is a continuous strip of concrete that supports load-bearing walls. It distributes the wall load evenly along its length. 4. Raft or mat foundation. A raft foundation consists of one large, reinforced concrete slab supporting several columns and walls. It is used when the soil has relatively low bearing capacity or when individual footings would cover most of the site. Advantages of shallow foundations. Shallow foundations offer several benefits. Economical compared to deep foundations. Faster and easier to construct. Requires less excavation. Lower labor and equipment costs. Easy to inspect and maintain during construction. Limitations. However, shallow foundations also have some limitations. Not suitable for weak or highly compressible soils. Cannot support extremely heavy structures. More susceptible to settlement if soil conditions change. May be affected by frost or groundwater in certain regions. Conclusion. To summarize, shallow foundations are one of the most widely used foundation systems in civil engineering. They are economical, easy to construct, and highly effective when the surface soil has sufficient strength. Choosing the right foundation depends on factors such as soil conditions, building loads, groundwater level, and project requirements. Understanding foundations is the first step toward designing safe and durable structures. Thank you for watching. If you found this video helpful, don't forget to like, share, and subscribe for more civil engineering content. See you in the next video.